So, in geology and earth science, we deal with two different types of time. One type of time is called relative time, and the other type of time is called absolute time. I'll start with relative time. With relative time, what you essentially do is you place events in a before and after sequence without reference to when they actually occurred. So to give you an easy example, it would be like if I said, Mr. Lodge is younger than Mr. Marsh, who is younger than Mr. Barry. You don't know how old Mr. Lodge is, or me, or Mr. Barry. All you know is that relative to each other, Mr. Lodge is the youngest, and Mr. Barry is the oldest, and I'm in the middle. So it's a sequence of events, and no numbers are allowed to be used. To the contrary, absolute time tells how long ago, and it involves numbers and it's specific. In fact, a lot of people refer to absolute dating as measured time, or absolute time as measured time. It refers to an exact date or time. For example, Mr. Marsh was born on September the 10th, 1980. That gives you an absolute date of when I was born, and obviously you know my exact age. In the course, we're going to do three different techniques, or learn about three different things that allows us to date absolutely. One is glacial varves, and what you'll learn is that a glacial varve is deposited in the lake in a glacial type area. And one varve is formed in 1 year and is made of two sedimentary layers. One layer representing spring and summer, and one layer representing fall and winter. Growth rings are tree rings, so the rings in a tree, and we know that one ring in a tree equals 1 year of growth. The biggest amount of time is going to be spent on the process of radioactive dating, and with radioactive dating, it involves isotopes, and it's a little bit more of a complex process that we're going to learn about. But what you can actually do is you can take a rock or you can take a bone, and you can carry out a process, and you can actually get an exact age of a certain rock or fossil. In terms of relative time, remember, relative time is never going to give us a number, but we will learn about different techniques that we can actually use or follow, that we can apply to understanding geology much better. So we're going to learn about the law of superposition, which essentially says that layers, sedimentary layers on the bottom are older, and as you go upwards, the layers get younger. We're going to learn about the principle of cross-cutting relations that says if you have a fault or an intrusion that cuts through or across sedimentary layers, then obviously the layers had to be there first, making the fault or the intrusion older. We're also going to learn about the law of original horizontality, which simply states that all sedimentary layers are deposited flat. So if you find sedimentary layers that are not flat, well, then you know that they must have gotten moved after they were first formed. The principle of inclusions simply helps us figure out in a sequence of sedimentary layers which is the top and which is the bottom. And once we can apply top and bottom, we obviously can apply the law of superposition to determine which layer is the oldest and which ones are the youngest. We're also going to learn about fossil succession. So we know that in sedimentary layers you can track the evolution of species on Earth. And so if you can figure out which layers are the oldest with progression to layers which are younger in age, you can also follow the evolution of life on our planet. We're also going to learn about unconformities, which are basically time gaps, missing time, missing rock from the rock record. And we're going to learn about three types of unconformities. So we're going to learn about an angular unconformity, a nonconformity, and a disconformity. So in the next video, I will start with basically teaching you guys the different types of techniques for doing relative time. And then later on, we'll eventually get to the different techniques for absolute time.